Hi friends, today we discuss the tokens and operators in C language. First we see the tokens. The smallest individual unit of the program is called token. C program is a collection of tokens. C tokens are classified into six types. They are namely keywords, identifiers, constants, strings, special symbols, operators. Let's see the C keywords. Keywords are the reserved words. It has predefined meaning. It will not be changed. Keywords are helps to build a program. All keywords are written in small letters. And we see that ANSI C keywords. ANSI C is nothing but American National Standard Institute of C language supports 32 keywords. And the given below table is the keywords which are supported by the ANSI C. And constants. Constants in C that do not change the value during the execution of a program. As we learn in the second session about variables in C, variable is used to store a value, and during the execution, the stored value may be changed or may not be changed. In the case of constant, the stored value will not be changed. It remains constant during the execution of program. Constants are classified into two types, numeric constants, character constants. As the name itself suggests that numeric constants, it will only store the numbers, integers and real values. And character stores characters and strings. And declarations. Constants and variables both be declared before they can be used. A constant declaration specifies the type, name, and value of the constant. We see the syntax and one of the example that const float pi equal to 3.5414. Here, const is a keyword, float is a data type, pi is a variable which we are assigning a pi value 3.14. This example says that how many number of times we execute the program, the pi value will not be changed. It remains constant because it is declared with a const keyword. And we see one example based on constants. As include stdio.h, as include conio.h. These are the header files and void main. We know that as C execution starts with main and const pi equal to 1.34, float and data type, variable r and area. Printf enter r value, it is used to print on the screen, and scanf it is an taking scanning, and area equal to pi into r into r. Printf area of circle percentage f comma r. The output is enter r value 18 and area of the circle. Here area equal to pi 3.14 into 18 into 18. Area of circle is 972.000. This is the way to execute a program based on const. Whenever we need that a variable will not be changed. It should be constant. Next, we see user-defined data type. There are divided into two types, typedef and enum. Typedef, typedef is used to provide meaningful name to existing data type. Syntax, type, def, existing data type, identifier. Enum. Enum is a user-defined enumeration data type supported by ANSI. And syntax we see enum, identifier, value 1, value 2, so and so value n. For example, we take enum is a keyword, day is a variable, and Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or the days or values days in a week. And next we see operators. In C Next we see the operators. In C language, operators are divided into 8 different types. Arithmetic operators, relational operators, logical operators, assigned operators, conditional operators, increment or decrement operator, bitwise operator, and special operator. And in this, the main operators and important operators are conditional, increment or decrement, and logical operators. Let's see arithmetic operator. Arithmetic operators are used to perform an operation between two operands. And we know that arithmetic addition, subtraction, multiplication, division, modulus. Addition is denoted with plus and algebraic expression x plus y, and examples of C code int x, y, sum equal to x plus y. Subtraction minus x minus y, float. Because we are taking float, when we subtract a value two values, we get a point decimal value, so that we are taking a data type as float. Multiplication, division, and modulus. It gives the remainder when an integer is divided by another integer. And let us take an sample code based on arithmetic operators. As include stdio.h, conio.h, void main int a equal to 18, b equal to 22, c equal to a plus b. It performs an addition operation of two numbers 18 and 22 and stores in a variable c. Similarly, c equal to a minus b, c equal to a into b, c equal to a by b, c equal to a modulus b. We get an output that a plus b equal to 40, a minus b equal to minus 4, a into b equal to 396, a by b equal to 0, and remainder when a divided by b equal to 80. Next, we see the relational operators. Relational operators are used for comparing purpose. The value of relational expression is either true or false. If the value is true, it returns 1. If the value is false, it returns 0. And some of the relational operators are less than, greater than, less than or equal to, greater than or equal to, not equal to. Let's see a basic program that hash include conio.h int main and int a equal to 5, b equal to 5, c equal to 10. Here we say that percentage d equal to percentage d. We have to note that single equal to is to assign a value and double equal to is to compare the values, compare the two values. That's why see here we have percentage d 5 equal to 5 equal to, if 5 equal to 5, it returns 1 because it is true. A is 5, b is 5, it returns 1. If the value is true, it returns 1. If the value is false, it returns 0. And similarly all the statements. Next, we see logical operators. And the logical operators are three: logical and, logical or, logical not. And logical and, if both the operands are non-zero, then the condition becomes true. And logical or, if any of the two operators is non-zero, then the condition becomes true. And logical not, it is used to reverse the logical statement of its operand. Is nothing but if A is true, B is false. True, false, false, true. Next, we see assignment operator. Assignment operator is represented by equal to. An assignment operator are used to initialize a value into a variable. For example, int x equal to 18. Int is a data type, x is a variable name. It assigns a value 18. That means the x will store a value of 18. And operators like equal to, plus equal to, minus equal to, multiplication equal to, divide equal to, modulus equal to. And we have some of the description and example. C equal to a plus b will assign a value of a plus b into c. C plus equal to a, it is an equivalent to c. C equal to c plus a. This concept is used whenever we want to reduce the size of the expression. We use this method, c plus equal to a. And next we see the conditional operator. Conditional operator works on three operators, so we call it as ternary operator. And conditional operator is denoted by question mark. Syntax: expression 1 question mark, expression 2 colon, expression 3 semicolon. For example, we see a greater than b. Printf a is greater or printf b is greater. This is nothing but the expression 1 is a condition. If the condition is true, expression 2 will execute. If the condition is false, expression 3 will be execute. Next, we see increment or decrement operator. Increment and decrement operator are unary operator because it works on one operator. Increment operators are represented by plus plus and decrement operators are represented by minus minus. And these are classified into two, that is pre-increment and post-increment. Pre-decrement and post-decrement. Pre, as we know, pre is immediately we have to take an action. Post means later we can take the action. We see an program, sample program based on operators as include stdio.h int main a equal to 10, b equal to 100, c equal to 10.5, d equal to 100.5. We see plus a equal to percentage d in the printf plus a. What I said plus a means immediately we have to take the action so that the value of 10 will be incremented to 11. So that's why we have an output that plus a equal to 11, and minus immediately we have to take an action 100 minus 199, and next plus c and minus d. Next, we see the bitwise operator. Bitwise operators are used for manipulation of data. These operators are used for testing the bits and shifting the bits. Note that the bitwise operator will not be applicable to both double and float data types. And bitwise operators are bitwise and, or, exclusive, or it is also known as XOR, NOT, and left shift and right shift. We see the special operators. Some of the special operators are comma operator, size of operator, pointer operator, member selection operator. And the size of operator is nothing but it returns the value of bytes. Suppose we have int is of 2 bytes. When we want to know the size of the data type, we write that size of int, it returns 2 bytes.